Hello everybody and welcome back. I hope you're all doing well. We're going to be looking in this video at question number 23. Mike and Elaine, not Elaine, Elaine. I wonder if I might start calling this Alan. I hope not. Mike and Elaine, unless it is pronounced Alan. I don't know. I never know how to pronounce these names unless there's something really basic like Mike. These two people play a game in which each player is equally likely to win. Very nice. The first player to win 3 games becomes the champion, and no further games are played. If Mike won the first game, what is the probability that Mike becomes the champion? Okay. So for a question like this, I might make a little bit of a probability tree. Okay. For our, we can have our first game, our second game, and our third game. And actually, we might need more games than that. If Mike's already won one, then either he wins 2 more games or Elaine wins 3 more games. So there's only going to be 4 games. So 4 games remaining. First, second, third, fourth, and the 5th game. So that's the 4th one after the current one. Okay. So we could say something like, well, Mike won the first game, and then, that Elaine didn't win. But there was a probability of 1/2 that Mike won the first game. Now, going after that game, Mike could win, or Elaine could win. And then after Mike wins again, Mike could win again, and Elaine could win. And then Mike could win, or Elaine could win. Notice I'm not continuing on here, because Mike has already won 3 games. Okay. Or Mike could win, or Elaine could win. Or Mike could win. Well, actually, no, that one wouldn't work either, because Mike's already won 3 games. So we could have Mike or Elaine again. Alright. I think there might be a better way to do this. I can't think of one off the top of my head right now. I also want to give myself more space. So we'll say Elaine wins the second game. Should probably keep everything lined up, shouldn't I? Okay. Or Mike could win and Elaine could win. Or Mike could win and Elaine could win. Or Mike could win and Elaine could win. Now again, I am not continuing on here because Mike has won 3 games. Or Mike could win and Elaine, or Elaine could win, and then Elaine has won 3 games, and so then it's Mike or Elaine. Now we just want the probability that Mike becomes the champion, right? So the probability that for each person to win a game is 1 out of 2. Each time they play a game, it's 1 out of 2. And the games that they play don't remember who won previously. So it's always 1/2 these probabilities. If you're not familiar with the technique I'm using, this is called a probability tree. Okay, and we just sort of line up or sequentially order our outcomes and assign probabilities. And, it's something that's worth looking up because it's helpful for a question like this. Now, what do we want? We want the probability that Mike becomes the champion. Well, when does that happen? That happens here, 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 and here. Everywhere else, which I guess I'll label in green, Elaine becomes the champion. Okay? You might say, oh, 4 of these branches give Elaine the championship, whereas 6 give Mike, but that's not how it works. With a probability tree, to figure out the probability of any one outcome, you multiply along the branches. Okay? So the probability that Mike becomes the champion after the 3rd game is 1/2 times 1/2, 1/4, which I think, just so I'm not confused, I will use a different color. We'll say 1/4 the chance that he wins up here. And then, well, what's the probability that Mike wins here? So 1/4, 1/4, or sorry, 1/2, 1/2, 1/2. So 1/8 the chance that he wins on his 4th game, having won his 2nd game. And then 1 half, 1 half, 1 half, 1 half. So that's 1 out of 16 is the chance that he wins on the 5th game, having won the 2nd game. Alright? So you can start to see how this is going. And with the halves, it's not becoming that hard to figure out the probabilities along these branches. Just how many branches do we go? So this Mike winning here and becoming the champion occurs after 1, 2, 3 branches. So 1 half to the 3 is an 1/8. Now you'll notice I am not paying attention to when Elaine wins. We're not going to deal with those probabilities. What we want to do is just calculate the probability of each of the individual ways for Mike to become the champion, and then add them up. So 1, 2, 3, 4, so 1/16. 1, 2, 3, 4, another 16th there, and that about does it. Okay, so we just want to add all these up. I guess I'll add them up over on this side. Quarter plus an 1/8. I suppose we could make these all base 16, so 16 plus 2 out of 16 plus 1 out of 16 plus an 1/8 is 2 out of 16 plus another 16th plus another 16th. 4, 2, 1 is 7, 9, 10, 11. So this should be 11 out of 16. Okay. If you want to double check these things, something you can do is you could say, all right, the probability that somebody gets champion is 1. We could figure out the probability that Elaine becomes champion. And that should be 5/16, and then the remaining amount of time, the 11/16 of the time, Mike will become champion. And so you could do that. There's going to be 1/16 of a chance of Elaine becoming a winner here, 1/16 here, 1/16 here, and then 1/8 here. And those do add up to 5/16. So we're looking for an answer of 11/16, and that's right in the middle. So we're going to bubble in C. Okay. So, probability trees are not that long to do, especially if you know what you're doing with them, which is why I recommend you look them up. Certainly this question should not be taking as long as I have taken, but I was trying to explain how probability trees work very slowly, because it's not something everyone has seen at this point. Okay, so up next will be question number 24. I look forward to that, and hopefully you do too. I'll see you there.